Good afternoon, everyone. We have built a customer support chatbot with case memory provided by Google Gemini that remembers past conversations and uses that knowledge to handle customer queries more intelligently. The goal is simple: faster resolutions, happier customers, and reduced workload for human agents. Today, I am going to walk through how we designed it, how it works, and why it is so effective. You have a problem with a product or service. Maybe your internet is down or your order is wrong. You contact customer support, you explain your issue, and then you get transferred. Now the new agent asks you to explain everything again. And maybe it happens a third time. It's frustrating and it wastes your time and it uses like no one really listening. So condense class design, database design, workflow, architecture diagram, tech stack. Let's start with the class design, which is basically blueprint for our chatbot system. We followed an object-oriented approach. Think of each class as a building block with a specific responsibility. User class. This stores details about the customer and their name, contact information, and most importantly, their interaction history. This history enables our case memory feature. Chatbot class. This is the brain of the operation. It receives queries, sends them to the AI model, and returns answers. It coordinates with other classes. Case memory class. This is where we store, retrieve past tickets, queries, and responses. If a user contacts us again about the same issue, this class ensures that they don't have to start from the scratch. Database handler class handles all data storage and retrieval operations. Escalation handler class. This decides if a query should be moved to human agent and manages that process. Here is an example. A customer asks about the delayed order. The chatbot class retrieves this query, checks the case memory for similar previous cases, finds that the order is already marked as delayed in the database, and instantly provides the update without asking respective questions. This is the power of the proper class design. Now let's talk about the database design. The database is the backbone of our system. Without it, the chatbot wouldn't have memory. We store four key types of data. User details, so we could know how who is contacting us. Second is chat logs. Every conversation is stored for future reference and quality control. Third is ticket information, which each use case gets a unique ID, status, and priority level. Next, fourth is escalation status. This tracks whether a ticket has been moved to a human and how it is progressing. For structured data like ticket IDs, customer profiles, we use a SQL database for reliability. But for quick search and retrieval of chat history, we consider NoSQL options for flexibility. Why does this matter? Because storing and retrieving the right quality data is what allows our chatbot to give relevant contextual answers instead of generic responses. Workflow. When a user interacts with the system, here is what happens step by step. The user sends the message, for example, I haven't received my order. The chatbot classes processes the input and sends to Google Gemini, interprets the meaning, and using natural language processing. The chatbot then queries the case memory to see if there is an existing ticket or relevant history. If the answer is found, say a note that order is arriving tomorrow, the bot instantly responds with that information. This process drastically reduces response time. Instead of making the customer wait while we look into their account manually, give them an answer in seconds. It also reduces the respective work for human agents because the system is already aware of the context. Workflow ticket escalation and check. Of course, not every issue can be solved instantly, but where ticketing and escalation come in. If chatbot can't provide direct answer, it creates a ticket and includes the issue details, customer ID, urgency, and other metadata. Now comes the escalation check. We have built the rules into our system. If the issue is marked critical, it is assigned to human immediately. If the ticket has been open too long without resolution, it automatically escalates. Example, if a billing problem isn't solved in 24 hours, the escalation handler routes it to the manager. This ensures nothing gets forgotten. Workflow, human handling, and closure. At some point, a human agent may need to take over. This happens if the problem is too complex for the chatbot. The user is frustrated. We can direct this to sentiment analysis. There is a legal or policy related matter, or once human resolves the issue, the system updates the ticket status to closed and stores all details in case memory. This is important because the same customer or another customer with same problem contacts us in future. The chatbot can use this history to respond without starting from zero. So architecture diagram. Here is how it fits together. User interface could be a website, chat window, a mobile app, even WhatsApp. API layer handles communication between the user interface and our backend. Gemini AI processing, where the chatbot natural language understands the happens. Database stores all user data, tickets, and chat logs. Human escalation system, a separate channel for assigning cases to live agents. The data flows from customer to Gemini to database and with back with escalation pathways available if needed. It's a smooth looped system. Tech stack. So our tech stack is designed for performance and scalability. Google Gemini API for NLP, it's a state of the art in understanding and generating natural language. Backend in Node.js or Python for handling business logic. Database in MySQL or MongoDB depending on the data type. Frontend in React or Angular for a modern responsive interface. And we choose Gemini for conversational quality and cloud hosting for reliability and mix of front end and back end tech flexibility. So our customer chatbot is with case memory is more than just a bot. It's an intelligent assistant that understands customer needs in natural language and remembers the past interactions to save time. Automates respective tasks, knows when to involve humans. The result, the faster service, less frustration, and better customer experiences. Thank you.